In this video, we are going to talk about orbital electronic configuration. We'll be dealing with 4 orbitals, which are the S, the P, D, and F orbitals. So, the S orbital can occupy up to 2 electrons. The P orbital can occupy up to 6 electrons. The D orbital can occupy up to 10 electrons, and the F orbital can occupy up to 14 electrons. Alright, in order not to waste time, how do we fill electrons into these orbitals? Filling electron into the orbitals, we have to follow some set of rules. The first principle we'll be talking about is Aufbau principle. Aufbau principle. An Aufbau principle just tells us that electrons are filled into orbitals in increasing order of energy. So it shows that the S orbital has lower energy than the P orbital, which has lower energy than the D orbital, which has lower energy than the F orbital. And then the Aufbau principle can be simplified by writing the orbitals in form of a tree. So we have 1s, 2s, 3s, 4s, 5s, 6s, 7s, 2p, 3p, 4p, 5p, 6p, 7p, 3d, 4d, 5d, 6d, and we have 4f, 5f. Alright, so when we are filling electrons into this orbital, we are going to go this way as this arrow is pointed. That is the order of increasing energy. Alright, so now how do we follow this? Let's try for sodium. How do we write the orbital electron configuration of sodium? And we know that sodium has atomic number 11. And remember, the shell electronic configuration of sodium is 281, right? Which means it has a total of 11 electrons, right? Okay, so now to make the orbital electronic configuration, we're going to follow the Aufbau principle. And then, which orbital do we start from? We start from 1s. So which means we are going to start from 1s. Then remember, how many electrons can go into an s orbital? 2 electrons maximum. So we can put 1s2. Do you get that? Then what is the next orbital? 2s. If you follow this arrow, you're going to see that the next orbital is 2s. So we have 2s. How many electrons can go into s orbital? 2 electrons. So 2s2. Then the next orbital is going to be 2p. Here, 2p. So we are going to have 2p. How many electrons can go into p orbital? 6 electrons maximum. Now we have 4 electrons filled out of 11. We filled 4. So we still have 7 left. So which means we can put 6 electrons into this p orbital. So if we make a count, 2 plus 2, that's 4 plus 6, that's 10. So we have 1 more electrons left to fill. So we filled 1s, 2s, 2p. The next one is 3s. So we are going to have 3s. Remember, we said that s orbital can occupy 2 electrons, but because we have just 1 electron left to fill, like I said, 2 plus 2, that's 4 plus 6, 10. We have a total of 11. So there's only 1 electron left, and we are going to put down 1 electron into 3s. So that means our electronic configuration is 1s2, 2s2, 2p6, 3s1. As simple as that. Alright, I believe you got that. Yeah. So let's try another atom. Let's do the electronic configuration of calcium. And you know, calcium on the periodic table has atomic number 20, right? You have to be familiar with at least the first 20 elements on the periodic table and know their atomic numbers, because when you are solving problems, you will not be provided with the atomic number. You just have to know the atomic number. All right. So the atomic number of calcium is 20. How do we write the electron configuration? To write the shell electronic configuration, we know that it is just 2882, right? If you don't know how to write the shell electronic configuration, check the last video on how to write shell electronic configuration. Now, how do we write the orbital electronic configuration? To write the orbital electronic configuration, then we're going to say follow the Aufbau principle. What is the first orbital? 1s. So we have 1s. How many electrons can go into 1s? 2 electrons maximum. Then the next one is 2s. How many electrons can go into another s orbital? That's 2s2. Now the next one is 2p, right? Following the arrow, the next one is 2p. So we have 2p. How many electrons can go into p orbitals? 6 electrons in total. So we can put 6 electrons into this 2p. Now we have how many? 2 plus 2, 4, 4 plus 6, 10. Then we are going to 20. We have 10. So we can keep filling. The next orbital is 3s. So 3s, that will get 2 electrons because it's an s orbital. What is the next orbital? 3p. If you follow the arrow, the next orbital will be 3p after 3s. 3p. Remember, p orbital can occupy 6 electrons. That will be 3p 6. Now let's count to know how many electrons left. 2 plus 2, 4 plus 6, 10 plus 2. That's 12 plus 6. We have 18. So 20 minus 18. We have 2 electrons left. So what is the next orbital? 4s orbital. So 4s. Remember that s orbital can occupy 2 electrons. So just put the remaining 2 electrons in the s orbital, 4s2. As simple as that. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That's it. So I believe now you can solve this one. Write the electronic configuration of solve for s. You can pause this video and try to write the shell electronic configuration and orbital electronic configuration of sulfur with atomic number s. With symbol s. Okay, so now what is the atomic number of sulfur? The atomic number of sulfur is 16. And the shell electronic configuration will be 2, 8, 6, right? For the shell electronic configuration. So how do we write the orbital electronic configuration? That will be equal to 1s2, the next one 2s2, 2p6, 3s2. Now how many electrons do we have left? 2 plus 2, 4, plus 6, 10, plus 2, 12. We are going to 16. So we have 4 electrons left, and the remaining 4 electrons will go into the 3p orbital, 3p4. I hope that is clear. Did you get it right? All right. Don't forget to like, subscribe, comment, and then make sure you subscribe so that you will not miss our next video. Thank you for watching. Bye.